Okay, so this is one of those questions which looks like it's quite difficult because there's just a whole bunch of letters and symbols and not very much information in there. But let's see if we can draw a sketch to start with to figure out, to give us a little bit more clarity. Okay, so we've got this function, and the values that we care about are from 1 to 6. So let me just 3, 4, 5, 6. Let's label that 1, 2, 3, 4, 5, and 6. And we know that the function from 1 to 4, x values from 1 to 4, is positive. So we're told it's greater than or equal to 0. So all we know is that the function is like above the x-axis from 1 to 4. And then from 4 to 6, the area under the function is a negative value. So let's say the function goes something like, well, so we don't really know what it looks like, but let's say it goes something like this. So that this area here is A, from 1 to 4. And this area here is B. In fact, it's negative B, because we're told that B is a positive number. Okay, so that's using the two bits of information that we got. So we were told that from 1 to 4, the area under the curve, which is what the integral is A. And from 4 to 6, the area under the curve is minus b. So that's this information. So that's using this information here to draw this picture. Now, for x values less than 1, we have no idea what it is. It could look like that. Well, not like that, but you know what I mean. And for values greater than 6, we also don't know what it looks like. It could look like something like that. Okay, so that's a sketch of the possible sketch of the graph. So the reason I've done that is because that's now going to help us figure out the answers to these solutions, to these sections. And in fact, now it's going to be quite easy. So the first part is the area between y equals 2 f of x from x equals 1 to x equals 4. Okay, so let's look at what that looks like. All we're looking at is from 1 to 4. So we've got this function that I've kind of sketched like that. So if it's 2x, everything gets doubled, so everything gets scaled up. And the rule for that is the area. So we're looking for the area equals the integral from 1 to 4 of twice f of x dx. And we can bring the 2 out the front. F of x dx. And this section here is just a, so that just becomes 2a. Okay, so that's the first part. Okay, the second part says what's the total area from 1 to 6. So we need to know from 1 to 6 of f of x dx. Okay, this is really easy because it's just these two areas added together. So we can just look at it from the graph and just go, okay, well, it's a minus b. But let's just do a little bit of working out. So to explain it, 1 to 4 plus from 4 to 6. Okay, which equals a plus minus b, which equals a minus b. Okay, so the second one is it's actually not that much harder. So it's saying what's the integral from 4 to 6 of 2x minus f of x dx. Okay, so now we're looking at the second part of the graph. So let me do my sketch again. So we've got this from 1 to 4 and 4 to 6. So we've got this area here and then this area here, which I've kind of drawn this way. So this is the bit that we're looking at. We're only looking at this part now. So again, we can separate those two. So it's from 4 to 6 of 2x dx. Take from 4 to 6 of f of x dx. Okay, this bit here we know is minus b. And this bit here we can just integrate. It's pretty easy to integrate. So that's x squared plus a constant, but we can ignore the constant, from 4 to 6. Which equals, so 6 squared is 36, take 4 squared, which is 16, which is 20. So 20, take minus b, so it's 20 plus b. Okay, and then the last one is the only real tricky part of it. So the question says, what is the integral from minus 1 to minus 4 of f of minus x dx? Okay, now it's worth me sketching this out here. So now we're looking at this section from 1 to 4. Okay, so what have I drawn the graph as? I've drawn the graph like that. Okay, we know this area is A. Now we're looking at f of minus x. So it's looking at the mirror image of this graph. It's a reflection of this graph here. So we're really looking at this area here. Here. Okay, so again, it's A. Okay, that area is A. We just don't know whether it's plus or minus. So let's have a careful look at the way the question's worded. So the unusual thing here is normally integrals have the lower number at the bottom and the higher number at the top. And they've got the other way around. So they've got the minus 1 at the bottom, which is actually bigger than minus 4. So we swap them around, and by swapping them around, we actually just put a minus at the front. So now we've got minus 4 to minus 1, f of minus x dx. And now, because it's that mirror image, that's exactly the same, leave the minus at the front, but it's exactly the same as from 1 to 4 of f of x dx. Okay, and that one there is a, so therefore the answer to this is minus a. So that last one is the only tricky one to get right, and it's only a case of just like looking at the original diagram and realizing that what we've got is flipped. So we've got a mirror image on the other side of the y-axis, and remember to put the minus outside because these numbers, the two ends of the integral, are the wrong way around. So to get them the right way around, it becomes a minus.